Volcanoes are mighty, they show Earth's great power. Fire and rock burst forth from their summits. Smoke and ash can fill the sky for miles. People watch these events with a sense of awe, but people also feel a deep sense of fear. These fiery mountains can be incredibly deadly. They remind us that nature is immensely strong. This power is ancient, raw, and has shaped our world. It has been doing so for countless eons. What is a volcano really when we look closely? It is often a tall mountain, conical in shape, but it is not just any ordinary mountain of rock. This special mountain has a hidden secret deep inside. Far below the ground there is a chamber. This chamber holds incredibly hot liquid rock. Sometimes this molten rock finds a way to escape. It rushes upwards and then bursts out dramatically. This sudden release is what we call an eruption. These spectacular eruptions do not happen by mere chance. There are immense and powerful forces at work deep within our planet. It is extraordinarily hot. Rock melts under this intense, sustained heat. Pressure builds up steadily, day after day, year after year. It is much like a gigantic pressure cooker buried underground. This enormous pressure needs to find a release point. The volcano, with its vents and conduits, is its escape route. The Earth must let off this steam, so to speak. So why does this fiery material choose to burst out? What are the specific triggers for these spectacular events? Understanding this process helps us to live alongside volcanoes. It is a compelling story of incredible heat and immense pressure. It is also a fascinating story of how our Earth is constantly moving. We will explore these fundamental reasons in more detail. We truly want to know what makes these volcanoes erupt. This knowledge is not just interesting, it is very important for us. It helps us prepare and protect lives. Deep under a volcano lies a substance called magma. Magma is essentially molten rock, intensely hot. It is rock that has become so hot it has turned into a liquid. This magma is typically found in a magma chamber. Think of this chamber as a huge underground pool of liquid fire. The heat is immense down there, almost unimaginable. The pressure exerted by the overlying rock is also very strong. This stored magma is the primary fuel for the volcano's eruption. It waits, sometimes for centuries, for its moment. Magma contains various dissolved gases within it. These are gases that have become trapped within the liquid rock. Water vapor from subterranean sources is a very common gas. Carbon dioxide is another gas frequently found in magma. Imagine a bottle of a fizzy drink like soda or champagne. The bubbles are trapped inside when the bottle is sealed. The gases in magma are in a similar compressed state. They wait for a significant change, a chance to expand and escape. This makes the magma even more restless and potentially explosive. As this restless magma begins to move slowly upwards, things start to change. It rises towards the Earth's surface, seeking a path of least resistance. The sheer weight of the rock above it gradually lessens. This means that the confining pressure on the magma decreases. When this pressure drops sufficiently, the trapped gases begin to expand. They form bigger and much more buoyant bubbles within the magma. This rapid expansion creates a powerful, undeniable upward push. It is very much like shaking that fizzy drink bottle and then opening it. This growing, relentless pressure from the expanding gases is key. It pushes the thick, molten magma with an incredible and gathering force. The magma searches for and exploits any weak spots in the rock above. Eventually, the internal pressure becomes too much to contain. It overcomes the inherent strength of the overlying rocks. The ground at the surface cracks and splits open dramatically. The magma, now called lava, once it reaches the surface, bursts out. This violent, or sometimes gentle, outpouring is the volcanic eruption we see. It can be a terrifying and awesome display of nature's power. Our Earth's outer surface is not one single solid piece. It is actually made up of several giant, rigid slabs of rock. These enormous slabs are known scientifically as tectonic plates. They fit together rather like the pieces of a huge jigsaw puzzle. These plates are always moving, though incredibly slowly. They float upon the semi-molten layer of the mantle beneath them. This constant, almost imperceptible movement shapes our world profoundly. It is the fundamental reason for many earthquakes and most volcanoes. The continents themselves ride upon these very plates. Sometimes, these massive tectonic plates slowly move apart from each other. This specific type of movement happens at divergent plate boundaries. Imagine two enormous conveyor belts moving in opposite directions. As the two plates separate, a significant gap or rift forms between them. Hot, buoyant mantle rock from deep below rises to fill this opening. This rock melts as it rises because the pressure on it decreases. This newly formed molten rock, or magma, then often erupts. This process frequently happens on the ocean floor, creating new oceanic crust. The Mid-Atlantic Ridge is a very famous example of this phenomenon. Plates can also move towards each other and eventually crash together. This type of interaction is called a convergent plate boundary. When a dense oceanic plate collides with a lighter continental plate, something significant occurs. The denser oceanic plate is forced to sink down beneath the continental plate. This geological process is known by the term subduction. As the oceanic plate descends deeper into the hot mantle, it gets hotter. It begins to melt, along with some surrounding mantle material, forming new magma. This buoyant magma then rises and can cause violent, explosive eruptions at the surface. Many of the world's most active volcanoes in the Ring of Fire are formed this way. However, not all volcanoes form precisely at these plate boundaries. Some volcanoes surprisingly appear in the middle of tectonic plates. These are often referred to as hotspot volcanoes by geologists. A hotspot is an unusually warm area in the Earth's mantle. Superheated rock, called a mantle plume, rises from deep within the Earth. This plume of very hot material creates a persistent source of magma. This magma effectively burns through the tectonic plate moving above it. The Hawaiian Islands, for instance, were entirely formed by such a hotspot. As the Pacific plate moves over the stationary hotspot, it creates a chain of volcanic islands. History tells us of many mighty and terrifying volcanic eruptions. Mount Vesuvius, located in Italy, is one such infamous volcano. In the fateful year of 79 AD, it erupted with sudden, shocking violence. It completely buried the bustling Roman city of Pompeii nearby. Hot ash, pumice and poisonous gases rained down for many hours. The city and many of its unfortunate people were frozen in time. This tragic event clearly shows the devastating potential power of volcanoes. It reminds us constantly of the significant danger they pose to nearby communities. We learn a great deal from studying these past cataclysmic disasters. Another incredibly famous and impactful eruption was that of Krakatoa in 1883. This formidable volcano was situated in Indonesia, between the islands of Java and Sumatra. Its cataclysmic explosion was one of the loudest sounds ever recorded in human history. It generated enormous and destructive tsunamis that traveled across entire oceans. Fine ash from the Krakatoa eruption spread all around the globe. It significantly altered weather patterns for several years afterwards. Sunsets became incredibly vivid and spectacular worldwide due to the atmospheric dust. Krakatoa demonstrated unequivocally that a single large eruption can affect the entire planet. Its effects were felt thousands of miles away from the volcano itself. We study volcanoes for very important, practical and life-saving reasons. The primary and most urgent reason is, of course, public safety. Scientists, who are called volcanologists, constantly monitor active volcanoes. They use arrays of special instruments to detect telltale warning signs. These crucial signs might include very small earthquakes or ground swelling. They also meticulously measure the types and amounts of gas emissions. This detailed information helps them to predict when an eruption might be imminent. Early warnings issued based on this data can save many thousands of lives. People can be evacuated from dangerous areas before a disaster strikes them. Studying volcanoes also teaches us a great deal about our own Earth. Eruptions bring important materials from deep inside our planet to the surface. By carefully studying samples of lava, ash, and volcanic gases, we learn about the complex composition of the Earth's hidden interior. We gain insights into the extreme conditions far beneath our feet. Volcanoes act as natural windows into the Earth's mysterious inner workings. They help us to understand how our dynamic planet was originally formed. They also show us quite clearly how it continues to change and evolve. This fundamental knowledge is vital for truly understanding our home in the cosmos.